Section 7.6 Modeling Data, Exponential and Logarithmic Functions. In this section, we are going to look at the graph of exponential functions and logarithmic functions, and then use the exponential model and also the logarithmic model. As you see the figure on the screen, so this is the model using the exponential function. As you see the trend of the data as it's increasing but not in the steady way, so it will not go with the relationship as the linear equation. And in this situation, the exponential function will be used to model this situation. What kind of exponential function? The exponential function with the base b is of the form y equals b to the power x. B is called the base and x as the power or the exponent of the expression. Or if you write in the term of the f of x equals b to the power x, where x is the input and b is the constant that refers to the base of this function, where the b is positive value and not equal to 1, x is any real number. If b is 0, we're going to get the function value as 0, and this is the case that nothing is applicable. And as well as the b equals 1, if b is 1, 1 raised to the power of the real number, the result going to return 1 for every input x value. So we are not going to consider that case as well. And then for the case that b is negative number, it will fall into some undefined case that we will not consider. So we strict the value for the b for the positive value or the value that is greater than 0 and also not equal to 1. The general form of the exponential function is y equals a as a coefficient multiplied by b to the power x. If b is greater than 1, this model is growing or the function is increasing at a rate proportional to their size. The number e or the natural number is about 2.71828 and so forth. This is the irrational number, which is not ending decimal number or not repeating decimal number. And this number we can use as the base b. If it is as the base b, or instead of the b, we write the e. This one is called the natural exponential function because the base is the natural number. Examples, we are going to graph the function f of x equals 2 to the power x. If the table is given in the form that you see, and the x as the input provided to be the value -3, -2, -1, 0, 1, 2, and 3. We're going to complete the table. The next column is a column of the function f of x, which goes with the 2 to the power x. So if the input, which is the value for the x, is -3, the value f of x is going to be 2 to the power -3. And the next one going to be 2 to the negative second, 2 to the negative first, to the power 0, 2 to the first, 2 to the second, and 2 to the third. And then simplify this number to be 1 over 2 to the third, which is 1 over 8. The next one is 1 over 2 to the second, or 1 over 4, 1 over 2, which is, you can write as a decimal number as 0.5. The next is 1, and then 2, and then 4, and then 8. For the values 1 over 4, which is 0.25, and the value for the 1 divided by 8, or 1 over 8, is 0.125. And the next column here, we're going to use it as a column for the order pair x comma y. The y value is a function value. Therefore, the order pair for the first one, I put it in this one, so going to be negative for the x, the y is 0.125. The next, the x is -2, the y is 0.25. and then negative 1, 0.5, 0, comma 1, 1, comma 2, 2, comma 4, and 3, comma 8. Now we get the order pairs X and Y, and we're gonna plot the graph. As the graph provided, as you see where X is negative 3, the order pair or the Y value is 0.125. So the order pair is located at negative 3, comma 0.125. And then for X equals negative 2, the order pair is negative 2, 0.25. So the Y value is a quarter or 0.25 right there. And the next order pair, when X is negative 1, negative 1, 0.5, the function value is a half or 0.5. And then the intercept, or this one is called the Y-intercept. When X is 0, the Y value is 1. The next order pair, when X is 1, Y is 2. When X is 2, Y is 4. When X is 3, Y is positive 8. The next example, now we're gonna sketch the graph of the function y equals 2 to the power negative x, okay? The power is negative, so let's identify the first column as the input column or the value for the x. The next one is the y, which is a function of the x that goes by 2 to the power negative x. If x is negative 3, y is 2 to the power negative of negative 3, which is 2 to the third power, or the value 8. Next one, 2 to the negative of negative 2, or 2 to the second, which is 4. And then 2 to the negative of negative 1, or 2 to the first, or just 2. 2 to the negative 0, which is the same as 2 to the power 0, or 1. Next, 2 to the negative 1, or 1 over 2, or just 0.5. 2 to the negative 2, which is 1 over 2 to the second, or 1 over 4, or 0.25, excuse me. The last one, 2 to the negative 3, or 1 over 2 to the third, which is 1 over 8, or the value 0.125. And the next column here would be the column for the order pair x comma y, because if we have the list of the order pairs, we're going to use the list of the order pairs and plot them on the xy plane and connect all the dots to form the graph of the given function. The order pair for the first one is of the form negative 3, comma 8, x first, y later, okay? And then negative 2, 4, negative 1, 2, 0, 1, 1, 0.5, 2, 0.25. And the last one is 3, comma 0.125. If the graphing the XY plane is not provided, but you have to sketch on your own. I would suggest you to look at the table and make a list. What is the lowest Y value? What is the highest Y value? For this case, I put a note here. The lowest Y or the Y minimum is 0.25, 0.125, sorry. And then Y maximum is the value 8. The x minimum is negative 3, x maximum is positive 3. So to manage your graphing area, you're going to use, make sure that the scale they cover the lowest y, the highest y, and the lowest x, the highest x. So I'm going to copy the graphing area from the previous one for our convenience. And then in this one, so we're going to get, oops, wrong one. So I'm gonna just do it by hand, sorry. So then what we have, since we know that the Y minimum has a cover 0.12, which is still positive side. So we're gonna look at the upper part of the XY plane. And then the scale for the X to the left up until negative 3, 1, 2, 3, to the right up to the positive 3. So 0 here, negative 1, negative 2, negative 3, 1, 2, and 3. And then scale for the y, the maximum is 8. Make sure we cover the highest value 8 and then break it up to a half, which is 4, and then one more half here. And next, this is 1, and then 3, and then this is 5, and this is 7. Okay, and next we're gonna plot the order pairs on the graph. The first one is -3, 8, where x, this is the x axis, this is the y axis. For the -3 for the x and then y is +8, the order pair will be up here. And then the next one is -2, 4, -2, 4. And next, -1, 2, 0, 1, 1, 0.5, 2 and a quarter, and 3 and 1/8. And the graph, as you see, the trend of the graph is decreasing. And just connect all the dots in the curve mode. So now we have the graph of y equals 2 to the power -x.